All right, this is the first video of section 3.3 where we're going to be using the different properties and characteristics that we learned related to polynomial functions in order to graph them ourselves, okay? So let's get right into an example here. We are asked to analyze and graph the function f of x equals x squared times the quantity x minus 2. So the first thing I want you to notice, I've given us the function in its factored form, which is really helpful in identifying everything we need to make the curve, okay? But also understand there is an expanded form to this function, f of x equals x cubed minus 2x squared. So that's going to be helpful in identifying a few pieces of info as well. So first, let's identify the y-intercept for this function. I know y-intercept is when x is 0, so f of 0 would be 0 squared times 0 minus 2, which results in 0. So we'll put a point right here. Then we go after the x-intercepts, or the roots of the function, as well as their multiplicities, okay? And this is where the factored form really comes into play, okay? The first factor is x raised to the second power. That's going to lead me to x equaling 0 with a multiplicity of 2. So I already have that point plotted because it's the same as the y-intercept. And then just recall that when the multiplicity is 2, that means the behavior of the graph near that point should be quadratic, like y equals x squared, okay? Our other x-intercept comes from the second factor of x minus 2. That means x will equal 2, and it has a multiplicity of 1. So at this spot on the curve, we should be behaving almost like a line, is what that multiplicity is stating, okay? Now, in behavior is going to be based off of the leading term of the expanded form of the function. So that would be f of x equals x cubed. So it's like the power function associated with the overall function, okay? There, your leading coefficient, your a value is positive, and then your degree is odd, okay? So based on those two pieces of info, I can tell you that as x approaches positive infinity, f of x should be approaching positive infinity. And then as x approaches negative infinity, f of x approaches negative infinity. So basically that's stating that the left side of the curve should be heading downward and the right side of the curve should be heading upward, okay? Lastly, maximum number of turns we know is based on the degree. Well, the degree would be this power of 3 here. So if the degree is 3, maximum number of turns is always 1 less than that. So there could be up to 2 turns for this graph. Okay? All right, so based on all of that information, I should be able to come up with a pretty good rough sketch of this curve here. So I know that the left side starts down low, the right side finishes high. I know I'm supposed to behave kind of like a parabola at x equals 0 and like a line at x equals 2, okay? Based on all of that, I can sketch the curve to be doing something like this. Okay. Now the one part of this curve that is probably not the most accurate is right here, this turn. That little local minimum right there, that is a guess. I can't tell you exactly where that turn should be taking place. This is where I would need some calculus to come into play, okay? So obviously we're not there yet. So for now, all I need you to demonstrate is that you understand that a turn does need to take place somewhere between x equals 0 and x equals 2, in order to get the end behavior of this curve as it should be. Okay. Also notice how many turns this curve has. There's a total of two turns, which matches what we answered in part D there. All right, let's do one more example together. This one's going to be a little more sophisticated. Here we have f of x equals -2 times the quantity of x minus 1 to the fourth times x minus 2 to the second, okay? Now, this would be a little bit more involved to multiply out. I don't really need to know the expanded version of the function completely. I just need to know that the leading term of this, if multiplied out, would be -2x to the sixth, okay? So where did the power of 6 come from? Well, you notice in the factored form, you have two variables, or two factors with variables whose powers are 4 and 2. It just means when I multiply this all out, the 4 and the 2 would add together to give me a 6 for the highest power, okay? All right, so y-intercept would be f of 0, which equals -2 times 0 minus 1 to the fourth times 0 minus 2 to the second. So that's -2 times 1 times 4, or -8. Let's put a point down here. X-intercepts, my first would be x equals 1. Coming from that factor, it has a multiplicity of 4, which means I should be behaving like a quartic power function there, y equals x to the fourth. Second would be at x equals 2. That comes from this factor, and multiplicity is 2, meaning I should behave like a quadratic, like a parabola right there. So we'll plot those. Okay. All right, now end behavior is going to be based off of this guy, that power function associated with f of x. Here a is negative, and my degree is even. So based off of that, as x approaches positive infinity, f of x should be approaching negative infinity, heading down. And same thing on the other side, as x approaches negative infinity, f of x should be approaching negative infinity, heading down as well. Okay? And then the degree of this function is 6, so that means my maximum number of turns could be up to 5 turns. Okay? And let me actually color code that a little differently. So that, recall, is coming off of the fact that right there is 6. Okay. Now let's put it all together. So I know I'm supposed to be low on both ends, and at both 1 and 2, I should be touching and turning around. At x equals 1, I should be a little bit flatter than I am at x equals 2, okay? So let's see. I'll be doing something like this. All right, once again, this spot right here, that is just a guess. I don't know exactly where that turn should be taking place. I just know I need to have a turn right there in order to get my multiplicities and end behavior to match up with what we've reasoned out. Okay. The other thing I want you to notice is the number of turns here. There's actually only 3 turns to this curve, not 5 like we said in part D, and that just goes to show you, why we have to stress the word maximum number of turns. There could be fewer than 5 turns, and in this case, it ends up being 3. Okay. All right, your turn to practice. You're going to go to practice 1. There you'll see a function already graphed for you, and you need to identify some key characteristics of that graph in order to come up with an equation in factored form to represent that function. Okay, pause the video, work through it yourself, and then come back, check your work.